Assalamu alaikum guys. Today we are going to start with the second part of your second phase of your chapter number 2, that is hydrostatic forces. So today we are going to start with the numericals. Problem number 1. The statement of the problem number 1 can be a rectangular plane surface is 2 meter wide and 3 meter deep. It lies in a vertical plane in water. Determine the total pressure and position of center of pressure on the plane surface when its upper edge is horizontal and A. It coincides with the water surface. B. It is 2.5 meter below the free water surface. If we want to draw the schematic diagram of this vertical plane surface that is submerged in the water, then we can draw for the A part when its upper surface is going to be have contact with the free water surface. Its upper level or the top level of the vertical plane surface having a contact with the free water surface. If this is the particular case, then the dimensions are given. The vertical dimension of this surface is 3 meter and horizontal dimension is 2 meter. We can point out the center of gravity and center of pressure like this, and we have derived this thing, and it is obvious now that our center of pressure is always below than the center of gravity. The distance of the center of gravity from the free water surface is going to be represented by h bar, and the distance of center of pressure from the free water surface can be represented by h steric. So if you are interested to determine the total pressure on this plane vertical surface that is submerged within the water, then we can have an equation for to determine the total pressure, that is F is equal to rho g A h bar. We have the rho as it is water. This plane surface has been submerged into water. So for the water, density is the standard 1000 kg per meter cube. G is also 9.81 meter per second square. What we can do, we can first of all calculate the area, the third parameter. First two parameters are known to us. This third parameter in this equation is the area of this plane surface. The area of this plane surface can be calculated by multiplying its dimensions. It is a rectangular plane surface, so its area to be calculated is very easy. That is 3 into 2, 6 meters square. Then secondly, the h bar can easily be calculated because for this rectangular plane, the center of gravity is just at the center of this vertical plane surface. So for this surface, it will be at h by 2, 3 by 2. So it's very easy to calculate. H bar will be going to be represent the center of gravity of this surface. So it will be 1.5 meter as it is a rectangular surface. Now if all of the four parameters are known to you, then the total pressure on this plane surface you can calculate by inputting the values in the equation. So here you are getting 88290 newtons as the total pressure force exerting on this vertical plane surface. Depth of center of pressure is given by the equation that we have already derived in our first part of hydrostatic forces chapter. So here we have the equation for the center of pressure, Ig over A h bar plus h bar. So in this equation, A is known to us for this surface, h bar is known to us. What is left to be determined, that is Ig, that is the moment of inertia about the center of gravity of this area. And its equation is also given, and we are known with the rectangular surface, it is BD cube divided by 12. So if you have the width, that is 2 meters, you have the depth, that is 3 meters, you can take cube of it and you can divide it with 12, and finally you are getting 4.5 meter 4. So in this way the center of pressure can be calculated by inputting all of the values, and you will get 2 meters as an answer. So in this way the first part has been solved, in which your vertical plane surface has been submerged in the water, that having a contact of the top surface with the free water surface. Now for the second part, your upper edge is 2 meter below the water surface. If this is the particular case, then you can draw or you can redraw your schematic diagram for the second case. For the second part, B part, your water surface is over here and the top surface of this vertical plane, rectangular plane surface is over here at 2.5 meter depth. So if this is the particular case, rest of the dimensions will remain the same. Then you can also represent the level of your center of gravity same as h bar, and the center of pressure same as h steric. Okay, so now you need to be add this extra depth or the level of the water inside all of the dimension. So your equation will remain same to determine the total pressure, that will be rho g a h bar. So rest of the values will remain same, just you need to recalculate your h bar. Now the distance of the center of gravity of this rectangular surface from the free surface of the water has been changed. Now this h bar is this distance, the half of the dimension of this rectangular area plus the depth of this rectangular area from the free water surface. You have to edit this extra depth into it. So now it will be 3 by 2, mean half of the depth of the rectangular area plus 2.5 meter distance. It will be 4 meters. So your h bar has been recalculated, and now you can input the respective value into the equation to determine the total pressure, and you are getting 235,440 newtons as an answer. You can also report your answers in kilonewtons, but better is to be reported in newtons. Now the central pressure is also Ig over A h bar plus h bar. So here again Ig is not going to be changed because the center of gravity will remain same, but means centroidal axis will remain same. And area is not going to be changed, it is a geometric property, so you are not going to be change the geometry, you are only changing the position of your plane surface. So geometry will remain same, then your moment of inertia and area will remain same. Only the distance h bar has been changed, and that we have already calculated 4 meters. You are going to be input your values in the equation of the center of pressure, and you are getting your respective answer as 4.1875 meters. So your center of pressure has been changed, and the new value you need to be report for the second case when your vertical surface, rectangular plane surface, has been submerged in the water at under the depth equal to 2.5 meters. So in this way you are going to be calculating your values, and it will give you the answer for the second part of your numerical problem. Now the problem number 2, you need to determine the total pressure on a circular plate of diameter 1.5 meters, which is placed vertically in the water in such a way that the center of plate is 3 meter below the free surface of the water. Find the position of center of pressure also. Here you have the plane surface, it is a vertical plane surface, but now the dimensions mean geometry has been changed. Now its geometry is not, the shape of this plane surface is not rectangular, it is circular one. For the circular plate that is submerged within the body at a depth of 3 meter from the center of gravity of this circular plate, and h steric will remain same, the distance is from the center of pressure, and again your center of pressure is below the center of gravity, you have to mark. So you need to determine the pressure and also the position of center of pressure also. So for that you have the dia. You can calculate the area of this circular plate very easily by inputting the value, the formula pi by 4 d square. So it comes out to be 1.767 meters square. H bar will be 3 meters. Okay, so it is given over here. This 3 meter is actually equal to h bar, the distance of the center of gravity from the free surface of the water. Total pressure can be calculated by the same formula, rho g a h bar. You have all the values with you. You can input for the water density and g value and a and h bar, and you are getting your answer in newtons like 52002.81. What about the position of center of pressure? That can be calculated by the same formula, Ig over A h bar plus h bar. So you have area of the circular plate, you have h bar that you have calculated earlier. Now only the Ig, moment of inertia, about the centroidal axis needed to be calculated. So for that you can take a reference from the previous theoretical part in which I have mentioned to you a table in which for the different shapes the moment of inertia about the centroidal axis and their respective formulae were given. So if you're going to be take the reference from that table, then you will get an idea about the equation that Ig is equal to pi d4 by 64. So it will be pi into 1.5 raised to power 4 divided by 64, and you are getting the answer as 0.2485 meter 4. And if the equation is with you, so you are going to be again inputting the same values and you are getting your answer as 3.0468 meters. So it's very simpler. If you have the formula for the pressure and if you have the formula for the center of the pressure, then you can input just the geometric properties and dimensions of the any surface and you can get the answer. Now, problem number 3. A circular opening 3 meter diameter in a vertical side of a tank is closed by a disc of 3 meter diameter which can rotate about a horizontal diameter. When the head of the water above the horizontal diameter is 4 meters, then you have to calculate A, the force on the disc, and B, the torque required to maintain the disc in equilibrium in the vertical position. Now, this problem statement can be well understood by drawing a schematic diagram. That must be the first step towards the solution. After the input data or understanding the problem statement, you need to draw it. If you are going to be draw a schematic diagram, then it will be easier to understand for you. So here we are going to be draw a tank and with a free water surface level, and you are going to be having an opening, okay, like this. So this opening you can see in a vertical plane. If you are going to be go inside the paper, then in transverse or the lateral direction, this opening will be like this, a circular opening you can see. Okay, so this diameter is total 3 meters. And if you are going to be draw an axis about passing through the centroid or center of this circular opening, then this is going to give you the center of gravity of this circular disc. So this circular disc has been going to be start from here and ending over here. So again I'm going to be explain you. This is the in this figure it is going to show you the front view of it. So if you are going to be have a side view, mean inside in the lateral direction, then it will be like this. So here the center of gravity is going to give you h bar equal to 4 meters, that is given to you, and for the center of pressure H you need to be calculate, and this force of on the disc you need to be calculate. Now, the geometric properties, first of all, dia, that is given 3 meter, and if dia is given area of the circular opening, you can calculate very easily by pi by 4d square. It will be 7.0685 meters square. Depth of the center of gravity h bar is equal to 4 meters. Force on the disc is given by the equation that we have already known, that is rho g a h bar, and you are inputting all of the values and you are getting your answer as 277.368 kilonewtons or 277.368 newtons. Now for the second part, you need to first of all find out that torque or the moment that is required to maintain the disc in equilibrium. So to maintain this disc in equilibrium, the central pressure is very important to be known at first. If central pressure will be known to you, then the movement of the forces about this central pressure that is going to be maintain your disc in equilibrium. So if the central pressure is needed to be determined, its equation is with you. So what is an extra parameter that is needed to be calculated over here to determine the central pressure? It is Ig, moment of inertia about the centroidal axis. So for the circle it is pi by 64d4, and rest of the values will remain same, and you are getting your answer as 4.14 meters. So if center of pressure is known to you, the force F is acting at a distance of 4.14 meter from the free surface. Movement of this force about the horizontal diameter axis xx, it will be the difference of the center of pressure and the center of gravity. Your force is going to be produced in equilibrium conditions once it is going to be produced a movement about the centroidal axis. So if we are going to be elaborated in a more particular way, then we have around the side of the tank. This is the condition when we have our circular disc. This is thickness of the disc in this way. It is shown over here. If this point is going to be show you the center of gravity, the G point, and here the force, hydrostatic force has been applied, this point is going to be represented by P, that is center of pressure. So the distance between these 2 points, mean if your hydrostatic force F is going to be produced a movement about the center of the gravity equal to this moment arm, that is going to give you h bar minus h steric, mean the distance of the center of pressure from the free surface and the distance of the center of gravity from the free surface. So this distance is, this moment arm is required to produce the movement of the forces or torque of the forces, hydrostatic forces about the center of gravity. So in this way you can very easily get that difference because both of the values are with you for the center of pressure and for the center of gravity. So if you're going to subtracting, so this difference is going to give you a movement arm that is going to be produced, a torque of this force, hydrostatic force, that is required to maintain your disc, circular disc, in an equilibrium. So this torque will be equal to 38831 Newton meter that should be applied in the disc in the clockwise direction so that your disc will remain in. Now next problem states that you need to determine the total pressure and center of the pressure on an isosceles triangular plate of base 4 meter and height 4 meter when it is immersed vertically in an oil of specific gravity 0.9. The base of the plate coincide with the free surface of the oil. So what you are going to be observing with this statement, I mean the difference from the previous numerical problems, like the shape of the plate or any surface that's a surface submerged in the liquid has been changed. Now it is not rectangular, not circular, it is triangular plate first of all. Secondly, it is an isosceles triangle. And thirdly, now the liquid has been changed. Now liquid is not water, it is an oil with a specific gravity of 0.9. So now you need to be very considerate about the parameters you are inputting in the equation to determine the hydrostatic force. And the last condition of this problem statement is the base of the plate coincide with the free surface of the oil. So if you are going to be considering all of these conditions of the problem statement, then you can draw the schematic diagram of this problem as well very easily. You have the free oil surface and you have the isosceles triangle. So if we talk about the schematic diagram, then the free oil surface having a contact from the base of this isosceles triangle. This base having a dimension of 4 meters and the vertical dimension, mean perpendicular of this triangle, is 4 meter. You can mark or you can report your center of gravity like capital G and the center of pressure is capital P, and as the same your center of pressure is below the center of gravity. So if we go towards the solution, then first of all we are going to be, unless the input parameters, those are the width of this triangle, that is 4 meter, the height or depth of this triangle, that is 4 meters. So if both of these dimensions are with you, then area of this triangle, isosceles triangular plane surface, can be calculated very easily. That will be half of the width into height. So it will be 8 meters square. Now, if we talk about the density, then the density needed to be determined by multiplying the density of the water with the specific gravity of the oil. Specific gravity is 0.9. So if you are going to multiplying the 0.9 with 1000, you are getting 900 kg per meter cube for this oil for which you are going to be solve your problem. The distance of the center of gravity from the free surface of the oil, h bar, is again needed to be calculated. Now you need to be very careful whether your base having a contact with the free surface or the tip, or mean the top of the other side of the triangle is having a contact with the free surface, or it is submerged in the water at a certain depth. Okay, now in this particular case, if base is going to be having a contact with the free water surface, sorry, free oil surface or liquid surface, then this center of gravity is going to give you the depth equal to half of, mean 1/3 of it. So from the base of the triangle, this distance of the center of gravity is 1/3 of h, and the rest of the dimension from the top or from the tip, it will be 2/3 of h. Okay, so you need to be very careful about that. If this triangle would be inverted, so the value of the h bar is also going to be inverted. So in this particular case, it will be 1/3 of h. So you are now, getting, if you are interested to calculate the total pressure, the first part of it, the problem statement, problem number 4, then we have the formula with us, rho g a h bar. You are going to be input your values and you are getting your answer as 9597.6 newtons. Center of pressure you can calculate by using the same equation. For that you need to be calculate Ig. Now the moment of inertia of the triangular section about its centroidal axis or center of gravity, it will be bh cube divided by 36. So it is a constant formula. You are just inputting the width and the height, and you are calculating your values as 7.11 meter 4. The central pressure can be calculated now by inputting your values in the equation, and you are getting your answer as 1.99 meters. Now problem number 5. A tank contains water up to a height of 0.5 meter above the base. An immiscible liquid of specific gravity 0.8 is filled on the top of the water up to 1 meter height. What you need to be calculate? Number 1, the total pressure on one side of the tank. Number 2, the position of the center of pressure for one side of the tank, which is 2 meter wide. The thickness of the tank is given over here. So once the forces will be with you, then by calculating the area of the pressure diagram, you can calculate the total pressure and correspondingly the position of center of pressure. Now, if we are going to be talk about the given data, then the depth of the water is given, that is 0.5 meters. Here you can see in the diagram on right side of the slide that one tank is going to be filled at the bottom with water, and above the water it is going to be filled with a liquid having a specific gravity of 0.8. So the depth of the water is 0.5, and above that the depth of the liquid is 1 meter. Specific gravity of the liquid is 0.8. How the density of the liquid can be calculated? By multiplying the specific gravity with the density of the water. So it comes out to be 800 kg per meter cube. And density of water is 1000 kg per meter cube. Width of the tank is 2 meter. That later on can be used for the calculation purpose. Now, if we talk about the solution of the first part, then the total pressure on one side, so it can be calculated by drawing the pressure diagram. It's very important because if only one tank be there, then the one liquid has been filled in a water tank or in any container, then the pressure diagram will be the linear one. The same relationship is going to be obtained. But if the different liquids are going to be filled within a container or within a tank, then the pressure diagram will give you the different slopes of the lines you will get because depending upon the specific gravity. So for that, if you're going to be start from the point A, then at the top, as H is equal to 0, then intensity of the pressure on the top, it will be equal to 0. Top of the tank, it will be 0. So at A point, your pressure will be 0. That is going to be represent the surface of your liquid with specific gravity 0.8. Second level, you can define the contact point, contact point of the liquid and the water. Okay, this surface. So if this surface is going to be represented by a point D, then from D to E, you can find out the pressure intensity that will be represented by PD, and it will be rho 1G and H1, depending upon the density of the liquid putting or filled above the water. And H1 is the height of all this liquid that has been placed above the water. So here you are going to be having the 800 density of the liquid, and 1 meter is the height of this liquid. So it comes out to be 7848 Newton per meter square. So this DE ordinate will give you the pressure intensity equal to 7848 Newton per meter square. Now if we talk about the base, then this base is going to be having the pressure due to the liquid plus the pressure due to the water. So if the rho 1G and H1 is the pressure due to water, plus you are going to be adding up an additional pressure exerted by this water liquid, and this pressure head is equal to 0.5. So it will be rho 2G into 0.5. So 1000 into 9.81 into 0.5. So if you are going to be adding up the pressure intensities caused by both of the liquids, then it comes out to be 12753 Newton per meter square. Now, if the intensities will be known to us at different levels, at point A, point D and point B, at the base of the tank, then we can very easily find out the forces. If F1 is going to be represent the force exerted at the center of gravity, or at the center of pressure of this area A, D and E, and F2 is the force that has been exerted or has had been applied on the rectangular area BDEF, and F3 is the force that is going to be applied on the triangular area EF and C. So this total pressure diagram can be distributed further into three different areas with the specific dimensions like triangle, one rectangle and another triangle. So if these three forces can be there, so we can sum up, calculate first of all individual forces for this pressure diagram, and for the total forces we can sum up all of these forces. So first of all, we can calculate F1, that will be equal to the area of triangle ADE into width of the tank. So we are considering the third dimension equal to unity. So width has been given, that is 2 meter. So you can multiply it with the area of this diagram and you can calculate the forces. So this forces will be equal to half of AD into DE and multiplied by 2. So in the lateral direction the width has been given. So if the total force needed to be determined, then it is not only going to be given the answer for the 2D case, you must be consider the third dimension in the lateral direction, that is width of the tank. So for the whole, including the height and the width in the lateral direction, so you are going to be considering the total force exerting on this tank due to this, first of all, first area. So it will be 7848 Newton. For the second area, it will be area of rectangle multiplied by the width of the tank, same 7848 Newtons. For the third, again it will be a smaller triangle with multiplying it with the width of the tank, and it is going to give you this answer. So in this particular case, you are going to be calculate the total force by summing up all of these individual forces. So F1 plus F2 plus F3, it is going to give you the answer 18148.5 Newtons. The second half of it, this problem is related with the determination of center of pressure. So how you can determine the center of the pressure? As we have already studied, that your center of pressure can be calculated by the rule or by the principle that the moment, or you can say produced by the resultant force, is equal to the moment produced by individual forces, or you can say the component of these forces. So on one side of the equation we can have the resultant, that is HP, center of pressure, that is going to be caused due to the total pressure exerted on this tank due to both of the liquids, and on the other side you can have the moments produced by the individual forces. So on one side we have F into H steric, and on the other side we have F1 into the moment arm from the center of gravity till the free water surface of the first area. Then F2 force multiplied by the the distance from the moment arm, that is the distance from the center of gravity till the free water surface of this tank. And similarly, the F3, the third force multiplied by the moment arm, that is the center of distance of the center of gravity of the third area till the free water surface. So if you are going to be considering the moment arm, so for the first force, you can see over here, it will be from the point A, this distance from the center of gravity of this first area will be 2/3 of this total distance, mean perpendicular, 2/3 of this perpendicular AD. And why? Because from the base it is always 1/3, and above the base till the top it will be 2/3 of the height, total perpendicular. So it will be 2/3 of AD. On the other side, if we talk about second, this rectangular part, for the rectangular part it will be the half of the dimension BD. So for FD it will be half of the dimension BD plus this AD. For the third area it will be 2/3 of EF, and plus you are adding extra AD into it. So AD plus 2/3 of EF or BD, it will be the same. And you are getting the moments arm for the individual forces for this pressure diagram. So from the right hand side you are getting the answer, and on the left hand side you have the total force that you have calculated in part A. You are inputting the values for the total force and the individual forces multiplying by its respective moments arm, and you are getting your answer as 18312. And finally the center of pressure can be calculated as 1.009 meter from the top. This reference point should always be mentioned in the answer. Okay, so you must be very careful, because if you are going to be calculating the central pressure from the bottom, okay, or from any other reference point, then these values or these moments arm will be different. If you are going to be calculating it from the top, mean from the surface of the liquid in the water tank, like A point, then your moments arm will be like this. So for the respective point, reference point, you need to be write in your answer that from where you are considering the moments arm. Those moments arm should be same for the resultant force and should be same for the components of these resultant force. So then you are going to be having a consistent answer that is going to give you finally the central pressure for the whole pressure diagram and for this one system. It comes out to be 1.009 meter from the top.